I'm going to focus this a little bit more on company building because, well, that's what I'm interested in. So, Tony, great to have you here. You've been in this space for a long, long time.
I think that's why I'm here, because I'm old, yes.
so please tell the audience a little bit about your background and what you're up to.
Yeah, I can give you two hats. I can give you a maybe a venture capitalist hat of running companies, in particular speech companies, and in particular speech companies using neural networks. And I can give you an academic hat where I was really fortunate to meet Jeff Hinton in '85, I assume, and pick up on the idea of what is now called deep learning at that time, 30 years ago, and do my PhD in that area and build it into speech recognition in the 90s, and now we're back in here again. So that's my take on it, is that I've been doing this for 30 years, and I would like to, we'll talk about that, won't we?
Yeah, I'm absolutely going to come back to that. Daniel, just a quick introduction from you before we do.
Yeah, I also wear two hats. The first one is I run a master's program in UCL called Business Analytics, which is applying machine learning to solving not just business problems, but societal problems. I lecture everything from entrepreneurship through to analytics. My PhD is in optimization, and my master's is in machine learning. And I've also spun out a few companies from UCL, the main one being Satalia, which solves hard problems for industry using algorithms, we'll talk about later.
Great. And so, what we're supposed to be talking about up here is kind of the future. And so let's start with the past. And, Tony has been in this space since the 80s, since the days of good old-fashioned AI. And I think deep learning and machine learning generally is kind of well up the hype cycle at the moment. It's all over the media, everybody's interested in it. But I would find it really interesting to hear from you that there are very few people who've stayed in this space. We've gone through a couple of AI winters, people have gone off and done other things, and it's gone out of favor. Love to hear kind of your history from academia through a couple of companies, what it's been like, what kind of technological advancement there's been, how did you start out, and kind of how have you got to now? So just give us a little snapshot.
Sure. So we made a lot of progress in late 80s, 90s, because we spent a fortune on designing what we called supercomputers, right? At the time, right? Big ring array processors, and these they did a gigaflop, right? And now, we got tens of teraflops or hundreds of teraflops now. But at the time, it enabled us to do research that nobody else can do, right? Now, was this great and was this pioneering? Or was it just a complete cheat because I got somebody else to pay for and did? All I did was the programming on it. So it's a really interesting idea, which is we started with, in a great environment. I had quite a character of a PhD supervisor who had 24 students. So he couldn't spend any time with us. So we just had to get on, find the interesting areas, do our own work, which was absolutely perfect for me. But we had a neural net winter. And I remember every year I was sent a questionnaire. Are you still doing neural nets? Right the way through the 90s. And everybody else, dropping off.
Why didn't you drop off?
I did, right. I have two hats, right? So from a company corporate hat, I was running a speech recognition company, which the result is now HP Speech. And we stopped. We didn't use neural nets because we couldn't get them to scale. We could buy lots and lots of cheap PCs and stack them really high and put a decent switch on them. And we, from a practical point of view, we stopped. on a day-to-day basis, of course, we started when we got GPUs, which we now have. And I have also interests in. I've run a financial engineering company, so I use neural nets to predict stuff as well. I don't know whether anybody else has done that, but there's a lot of interesting stuff you can do out there, but you have to balance the what you can achieve now if you're running it as a company thing, but we can fairly. There's probably the only prediction about the future I'm going to make is we are going to get more compute. It's going to become cheaper and cheaper. I've lived through a factor of either 1,000 or 10,000 so far, probably a lot more from early BBC Micro days. And give it another factor of 1,000, things are going to look completely different again. So it's going to be really interesting. It's going to be fun.
And so, Speechmatics specifically, you've been working on this 9 or 10 years.
Mm-hmm.
Tell us about technological advancements in speech recognition. What have you come from? What problems have you solved, and where are you now?
Well, we want to. We want the Star Trek, don't we? Everybody wants Star Trek. Just talk to a computer and it works, and it's getting a lot better. And two of the reasons it's getting a lot better is we're applying the neural nets, the recurrent neural nets specifically from my PhD, which is why I couldn't just retire and just sort of say, let somebody else do this, because they are now so useful in both acoustic modeling and speech recognition, which is just getting from the waveform that gets digitized in the microphone to estimates of the phonemes being said, and predicting one word from another. And this gets into all of the word embeddings, and they are really good. They are halving the, we have some really big neural nets doing this, but they are halving the number of things that we have to consider for the next word coming up. And I've run PhDs in this, and we've got 5% reduction. We saw no difference in word error rate. And now that we can actually halve the number of things that we predict, we see 20% relative reduction in word error rate. And this is the first time that language modeling has really made any difference to speech recognition. And even if you get it to ramble on its own, it starts making up some fun stuff. Whereas before, it just it's gobbledygook, right? So getting it just to ramble on. So yeah, we're really getting somewhere.
Interesting. And I want to come back to the impact of that on sort of applications of the future. But Daniel, to bring you into this, tell the audience a little bit about Satalia. What technologies you use and how you fit into this picture.
Yep, I think deep learning is being made synonymous with AI, and I think it's really important to try and understand what AI is. Can anybody actually tell me what the definition of AI is? Out of curiosity. No?
Please do.
Well, I don't know.
It's what computers can't do yet, right?
Not necessarily. The best definition of intelligence that I've ever come across, I can't remember the authors now, is goal-directed adaptive behavior. The idea is that you have a goal that you're trying to achieve, and you can behave in a way to achieve that goal. And the faster and smarter that you can adapt to achieving that goal, the more intelligent you are. And artificial intelligence is, can we create something that can artificially achieve goals and adapt to achieving those goals? I think that's a nice, simple definition. And I think that artificial intelligence, there are two big problems that are confused. The first problem is around pattern recognition. And actually, that's what neural networks, that's what biologically inspired AI is very good at. We're really good at recognizing patterns. And now we are, because we have deep learning, we can do neural networks on steroids. So if we point our cameras at the room, it can pick out the humans, it can pick out the glasses and things like that, which is great. We do that automatically all the time. We don't have to think consciously about picking out all of these different things. It all happens subconsciously. Those of you that have read Thinking Fast and Slow by Daniel Kahneman, he talks about two types of brains, the fast brain and the slow brain. And biologically inspired AI is very good, or predicted to be very good, at pattern recognition. But humans are terrible at solving problems, actually. So if you ask a human to go and book a holiday next week, that's the slow part of your brain. It has to not just recognize all these patterns, but then do something interesting with them, essentially solve a problem. And we're really not very good at that. I can give you lots of examples in a minute and show you why we're not. And so what Satalia does is it focuses on that last part. It solves hard problems, and that it doesn't use biologically inspired intelligence. It uses algorithmic or symbolic inspired intelligence. If you think back historically, and I wasn't fortunate enough to be conscious really in the 80s, that was when I was born, but that's I guess when we had the neural networks, and well, actually neural networks was kind of 80s, 90s. Before then we had what is called symbolic AI, symbols. We have, if Socrates is a man and all men are mortal, then we can imply that Socrates is mortal. So these are symbols, and from these symbols we can make inferences from them. That's symbolic AI. And then we had biologically inspired AI, which is some sub-symbolic AI, which is neural networks, which peaked because we didn't have the compute power available. In the 2000s, we had agent-based systems, which is a renaissance of symbolic AI. And now we're having a renaissance of some sub-symbolic AI. We're having a renaissance of neural networks. And I think that what will happen is that we're going to start to have problems because those biologically inspired neural networks are going to have the same problems that humans have, which is not being able to solve hard problems like timetabling, like routing, like staff rostering, like booking a holiday. And I think you need a different type of AI to solve that problem, and that's where Satalia is. Those are the types of algorithms that we use to solve problems. Does that make sense?
Yeah, no, that makes a lot of sense. And I want to come back to, I'm going to pause the future predictions for the moment, so I want to come back to that. But I want to actually talk a little bit about the company building side of this, because that, solving optimization problems or solving hard problems sounds like a great product that a lot of people can use. But one thing we look for in venture, is these big scalable companies, things that you can productize and then scale with very few people. I guess my question to you with Satalia and other similar companies, how much of that is a consulting service that you need to, tailor for each specific problem that you come across, and how easy is it to productize and make that into a platform?
It's a great question. We're currently working for a big retailer doing vehicle routing. Now, vehicle routing doesn't sound very sexy. It's a big optimization problem. If I give you 20 points on a map and ask you to tell me what the shortest distance is around those points, there's no human alive that will be able to give you an answer in a very quick time, or a very good answer in a very quick time. You need to apply optimization algorithms to that. So actually, those types of problems can be really well productized and solved for organizations because you can show value in solving these problems better. I think everybody's really excited about prediction, of using these types of techniques to find patterns in data, to do pattern matching, to find prediction. But I think the real value is being able to act upon those predictions. I might be able to predict very accurately that next week there's going to be a higher crime rate in a particular area because I've brought various data sets together and I've applied deep learning to it. But then what I have to do is I have to allocate my resources in a really, really smart way. I have to move police over there. I have to move this over here and this over there. And if you do that badly, then you're not making the best use of your predictions. So I think it's really important to let's figure out what are the problems we're trying to solve and how can we measure the value than just finding patterns in data.
Yeah, no, and speaking of solving problems, so I want to sort of look at the future through a few lenses. One is kind of problem solving and company building. Another, I'd love to get some of your thoughts on speech recognition and kind of interfacing with machines in different ways. And then I guess there's this general kind of what's happening in deep learning next. But let's start with the corporate side of that. Both of you have been in and out of academia. Both of you have spun companies out of universities. What do you think the future for startups in machine learning is? Do they come out of universities, or is it all Google and Facebook because they've got the engineers and they've got the data? Where's the future in this stuff from a corporate perspective?
Yeah, I would like to say that basically go for it. It's easy to start companies now. The compute is very cheap. You can just what's it going to cost you? It's going to cost you £1,000 to get a PC in your bedroom with a decent graphics card, 2,000 maybe, you know, high-end graphics card, and just go for it. All of the hard stuff in running companies is just disappearing. So if you're small scale, you can definitely start on your own, and it's something that I really enjoy doing. So that's why I'm enthusiastic about it. But there is obviously advantages in working for a company that's got a lot more compute than that, and to have people around you to bounce ideas off. But we've got a lot more communication now than we had. Very easy to meet people and to get ideas and to build things. So,
but what about this cold start problem? You know, like a lot of the companies we meet, and I think a lot of academics, machine learning requires huge amounts of data which is constantly updated. And I think it's hard as a young company or even as an academic to get your hands on kind of relevant data to build a system. Do you think that there's this incumbency advantage which is going to be hard for certain applications, or is it possible to overcome that?
You're talking to somebody who ran one company by sitting in his office in the when I was a lecturer in the Cambridge University, with a dedicated phone line at, what was it, 14.4 kilobits a second back to my work computer to run my programs. And there's the internet's out there, you know, there's stacks of data. If you want to do anything to do with words or images, or you're not short of data, and you know, what the terabytes of hard disk cost? Virtually nothing. So we're not short of data to build interesting systems.
Okay. Daniel, I mean, you have this double hat at UCL. You know, you're involved in spin-outs.
Yeah, I think there are two types of companies, and Satalia is trying to be both, which is you have lots of compute now, and people thought that by providing people with lots of compute, it's going to stimulate lots of innovations, and it didn't really happen. Then the idea now is we can give people lots and lots of data and lots of compute, and now all of these startups are going to come along and kind of find new innovations in that data and compute. And actually, I'm also skeptical about whether that's going to happen. I think when you're a small company, a startup, you need to solve a problem for somebody for them to give you some money. You need to provide value. That's one type of company, somebody that is trying to solve a problem for an organization. And so it's okay for organizations to kind of open up their data, but they've also got to open up their problems and say, it's really valuable, actually, if you can use our data to solve this problem. But companies are really reluctant to do that. They don't want to tell people that they have problems. They want to talk about being innovative, but that's not just about opening up data, it's opening up your kimono as well. So there's that type of company, and you need to build products and services to make money, to sustain yourself, to keep the lights on. But then there's the other type of company that just builds something really cool, like DeepMind. You get this thing that can play a computer game. And there's no revenue model there, right? We're going to build this thing, and it's going to be really cool. And if you're fortunate enough to have money in the bank and things like that, then you can go and do that. It's risky, but it's also, as we can see, very high value. Satalia is it has to do both. I don't have enough money in the bank to do something cool, so I have to build solutions for casinos to roster their staff, for telecom companies to place mobile phone masts, all optimization problems. Companies, grocers to route vehicles. These are all optimization problems. But my cool thing that I want to do is that when you pick up the phone and you say to Siri, tell me the weather tomorrow. Siri will use weather and tomorrow, and it'll do a pattern match. It'll use the deep learning to go and return that answer. But if you say to Siri, book a holiday for me next week, actually, what it has to do, it has to go and look at your bank account, your preferences, your history, lots and lots of different things. It has to go and recognize lots of patterns. Then it has to bring them together and then solve a problem. And I want Satalia to be the engine solving all of those problems. So when you say in Star Trek, computer do this, and it's actually a hard problem, I want to be the algorithmic engine solving that problem.